Okay, so I mentioned in the last video that I was gonna provide some kind of insight and a few tips on what to set to U and what to set to DV. And you probably stumbled across this in your Calc 2 course. I didn't. Um, I don't know what it was like at CCNY to take Calc 2. Um, and I generally don't use this, but when you first get introduced to integration by parts, you sometimes are guessing on what to set to U, and if you chose the wrong one, then you scribble it all away and re- restart all over again, picking the other function to be your U. But this generally works most of the time. And when I was looking up videos on this mnemonic, um, Black Pen, Red Pen made a pretty good video on it, very quick one that I'll put down in the description below. But with that, I just wanted to show that this exists, but we're not going to be using it religiously, especially for integration level uh, integration Bs. And for the most part, if you're just starting out with integration by parts, um, you're not going to really use this religiously. You build some kind of internal muscle, and it's just experience gained through solving problems that you know which one is the preferred function to set to U and dv. So with that, let's go ahead and start uh, a couple warm-up problems, and then we'll go ahead and start solving some more fundamental and trivial. I mean, so the way this works is if we have the integral we began with, uh, let's say the integral of x sine x dx, and this could be, x squared, x to the fifth, doesn't matter. Um, the way you use this mnemonic is we start from top to bottom, and if we see a function is in our integral, we go ahead and set that one to U. There's no logarithms. There's no inverse trig functions. There is an analytic function, x to the fifth, and that comes before trig functions. So we're going to set our u equal to x to the fifth, and that's right, because it differentiates to 0, and the integration by parts works smoothly. But what we'll come to realize is with more difficult integrals, that's not always the case. So we'll start off with some calm, fundamental, must-know problems, and then we'll go ahead and build the difficulty from there. Okay, our first problem. Integral of x to the fourth times e to the negative x. So, well, we know we'll set u equal to x to the fourth, because it differentiates all the way to 0, so using the DI method. The DI method is sometimes referred to as tabular integration because we make these rows and columns, and you'll sometimes see a third column where we put the sign. So we put the plus, minus, plus, minus, plus, minus. And they're essentially the same thing, only difference is one takes a lot more time drawing out the lines for the rows and columns. But yeah, we set x to the fourth in the d column, and our exponential will be in the integration column. And we differentiate till 0. So we get 4x to the third, 12x squared, 24x, 24, 0. And now we integrate. What's the integral of e to the negative x? Well, it's just e to the negative x divided by negative 1. We do it over again. E to the negative x divided by negative 1. And pretty straightforward. And now, multiply, 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 multiply. And what do we get? The integral equals x to the fourth minus x to the fourth e to the negative x minus 4x cubed e to the negative x minus 12x squared e to the negative x minus 24x e to the negative x minus 24 e to the negative x. I would say don't forget a plus c, but for our purposes, for the integration b, you are not required to put a plus c. You will not be penalized for getting a plus c, so from now on, we're just going to omit putting c's, integration constants, into our solutions. So this is perfectly viable, and yeah, let's move on to the next one.